Bismillahirrahmanirrahim. Assalamu alaikum students. This is your chemistry teacher Farzana Nazir. Today we are going to continue chapter 5, that is physical states of matter. Today we are going to study some typical properties of liquid like evaporation, vapor pressure. Another property which is exhibited by liquid is boiling point. We are going to discuss it in next lecture. Now, after going through these topics, students will be able to explain the process of evaporation. They can easily visualize and understand the principle behind the changes in liquid state in their surrounding. As you know, different chemical changes occur in our surrounding, and you can easily identify which process is evaporation. You can easily explain the effect of temperature on rate of evaporation and vapor pressure. Now, today we are going to study another state of matter, that is liquid. As you know, there are many kinds of substances which exist in liquid form, but the most common liquid form that exists in our surrounding is water. Water is used in our daily life. It is used for cooking, washing, drinking, and it is used for many industrial purposes. If we look at the particle nature of liquid, we will find that liquid molecules are apart from each other. They can slide past one another. Because of this, liquid has definite volume and definite shape. The intermolecular forces are stronger than in gases. Now, some typical properties of liquid are: number 1, evaporation. Number 2, vapor pressure. Evaporation. As you already know that the water evaporates from sea and oceans. This water vapors rises up and form clouds and come down as rain or snow. Now, let us perform an experiment to find out whether the evaporation takes place in our surrounding. It is very useful for us because through evaporation we get pure salt. Let us enjoy the experiment. Perform a simple activity. Place a beaker containing water on the burner. Let the water to boil. Continue heating the water. It turns into steam and evaporates. Add some spoons of salt in water and stir it well. Salt gets dissolved. Now heat the salt solution. The water is gradually evaporated, leaving the salt behind. Seawater contains different kinds of salt. Common salt is one amongst them. Seawater is allowed to stand in shallow pits. Water gets heated by the sunlight and slowly turns into water vapors due to evaporation. In a few days, leaving the salt behind, the water evaporates completely. Common salt is then obtained. It is our common observation that when we wash our clothes and hang them outside, after some time, you will observe that they dry up. Similarly, if we drop water on the floor, after some time, the water vanishes. Where do this water go? This water from the floor or from the cloths actually evaporates. So what is evaporation? conversion of liquid to a gas or vapors at all temperature is called vaporization or evaporation. Evaporation is a surface phenomena. It takes place at all temperature below the boiling point. All the molecules of liquid do not possess equal energies at any temperature. So they move with different velocities. When the high energy molecules hit the molecules on the surface of the liquid, they give part of their energy to surface molecules, which become able to overcome the attractive forces and thus leave the liquid surface. In this way, evaporation takes place. There are different factors which affect evaporation. First is force of attraction. When we put some liquid such as water and ether in an open container, you will observe that the water evaporates to a very little extent, whereas the ether evaporates quickly. This is due to the strong forces of attraction present between the molecules. Greater the forces of attraction, less is the rate of evaporation. Or we can say, less the forces of attraction, greater is the rate of evaporation. During evaporation, high kinetic energy molecules escape first, and lower kinetic energy molecules are left in the liquid. As a result, the temperature of the liquid decreases, and this decrease in temperature causes cooling. So we can conclude that during evaporation, cooling process takes place. Evaporation is a cooling process. Let's see some example of this process to prove that actually evaporation causes cooling. We will perform an experiment. When we put nail polish remover on our palm, we feel a sensation of coldness. Now, if we put a nail polish on our palm, it disappears in a few seconds and the palm feels cold. This is because all molecules in a liquid do not have same kinetic energy. Most of the molecules have average kinetic energy. Some molecules have higher energies. These high energy molecules are able to break away the intermolecular forces and escape as vapor. The average kinetic energy of the remaining molecules decreases. These molecules absorb energy from our palm, and in this way they increase their kinetic energy and escape into the surrounding. Another example is of earthen pot. Water in earthen pot remain cold even in hot summer days. This is because earthen pot has small pores in it. When we keep water in it, this water seeps through these pores and evaporate. As the water evaporates, it extracts heat from the water present in the pot. As a result, water in the earthen pots remain cold even in summer. Here are some other examples of evaporation. Now the second factor which affects evaporation is temperature. If we increase the temperature of a liquid, it increases the kinetic energy of the molecules. As a result, more surface molecules overcome the forces of attraction. Because of their kinetic energies, they collide with molecules more sufficiently. As a result, the attractive forces are overcome by the molecules. As a result, they escape as vapor in their surrounding. Hence, we conclude liquid evaporate faster when heated. Now, the example for effect of temperature on evaporation is, it is our common observation that wet cloths dry quickly in summer than in winter. Why? Now you can answer this question easily. As you know, in summer temperature is higher than in the winter. Greater number of water molecules absorb the heat, and as a result they escape as gas in the atmosphere. As a result, the rate of evaporation increases. That's why wet cloths dry quickly in summer than in winter. Let us study another property of liquid, that is vapor pressure. The pressure exerted by the vapors of liquid in equilibrium with its liquid is called vapor pressure. The evaporation of a liquid in a closed container is somewhat different. Notice that in the closed container, no molecules can escape into the outside air. When a partially filled container is sealed, some of the liquid molecules evaporate. As the time passes, the number of molecules changing into vapors increases. This is evaporation. Some of these molecules, because of their random motion, will collide with the liquid surface. Such molecules are recaptured by the molecules at the surface of the liquid. This process is called condensation. These two opposing processes will continue. After some time, the number of molecules evaporating will become equal to the number of molecules condensing. At this stage, equilibrium is established between liquid and vapors. At equilibrium, liquid continues to evaporate and condense, but at equal rate. The pressure exerted by the vapors of a liquid in equilibrium with its liquid is called vapor pressure. At equilibrium, the space above the liquid is saturated with vapors. Now, let us study the effect of temperature on vapor pressure. Vapor pressure of a liquid changes with temperature. Increase in temperature increases the kinetic energy of the molecules. The molecules of the liquid at high temperature collide with the molecules more frequently. As a result, they overcome the attractive forces present between them and escape as vapors. So, vapor pressure increases with temperature. This process, that is increase in temperature, increases the vapor pressure of the liquid, can be proved by an experiment. Now, let us watch the experiment. A liquid is confined in a cylinder as shown in the picture. The liquid exerts a vapor pressure in the space above it. The molecules continuously transfer back and forth between the gas and liquid. The gas pressure in the cylinder represents the vapor pressure of liquid that results from equilibrium. As the temperature of the cylinder is increased, the average kinetic energy of the molecules increases in both liquid and gas phase. At high kinetic energy of molecules facilitates the escape of molecules from the liquid phase to the gas phase. At the same time, gas molecules are less likely to return into liquid. This increase in temperature increases the vapor pressure of a liquid. Now, at the end of this lecture, let us review what we have studied today. Conversion of a liquid to vapors is called evaporation. It is a surface phenomena which takes place all time at all temperatures. Stronger the forces of attraction, lowers the rate of evaporation. Evaporation is a cooling process. Increase in the temperature of liquid increases the rate of evaporation. The pressure exerted by the vapors of a liquid in equilibrium with its liquid is called vapor pressure. I hope you have understood the lecture. Now I am going to give you some questions which are to be solved in a very easy and simple way. Write it in your own words. Question number 1. What does evaporation lower the temperature of a liquid? As I have already told you that during evaporation, high energy molecules evaporate, leaving the low energy molecules behind. As a result, the temperature of the liquid decreases. This is the main principle behind this. Second question is differentiate between evaporation and vapor pressure. You have to write 3 differences between evaporation and vapor pressure. First difference will be the definition. Second, evaporation is a surface phenomena, whereas vapor pressure is not a surface phenomena. Third difference is the example of both the processes. Question number 3. Is evaporation a cooling process? We have discussed it in detail. Write the answer of this question and give one example. Question number 4. Liquid evaporates faster when heated. Why? Now this question is related to question number 1. Read the question carefully and then answer in a simple way. You can also give an example for this process. Submit your exercise within 24 hours so that I can mark your presence. Thank you.